This video is a follow-up to the first video on discounting cash flows. In this one, I want to show how a spreadsheet is super useful for showing multiple future payments and what they're figuring out through the discounting cash flows formula, what those multiple payments are worth today. So the formula for discounting cash flows is written here in cell A7. It says PV equals FV over 1 plus Y raised to the power of N. In plain language, that means present value, what we would value something today, can be calculated by starting with a future value, some known amount of money, and then dividing that by 1 plus the discount rate, which is also known as yield or IRR or growth rate, but in the discounting cash flows world we call it discount rate. And that number, 1 plus Y, is raised to the power of N. All of that in the denominator or the divisor that divides future value. So discounted cash flows, just to remind you, is super useful for calculating future payments, like what's the value of a pension payout, or what's the value of an annuity, or frankly, what's the fundamental value of a stock or a bond. It's the basic skill of investing. It's useful for what are those future Social Security payments worth. I'm going to use an example here that's simple of comparing two deals that I was offered that I made up. But let's say a content creation company says, Mike, you're really good at making videos. We want to contract with you for more Excel videos on YouTube. And in the first case, scenario 1, we want to offer you payments of $5,000 per year. That's spelled wrong. Scenario number 1. $5,000 per year for the next 5 years to be our content creator. I'm going to number these payments 1, 2, 3, 4, and 5. And I'm going to just drag, and if you know autofill, you can just click this button and drag $5,000. So this is year number 1, numbers 1 through 5, and in the scenario I'm being offered $5,000 each for a total, and I'm going to show the total by doing the sum function equals sum, parentheses, there. $25,000 is the contract on the table, and I want to compare that to scenario number 2, which I'll write over here. I should have done all caps the first time. Scenario number 2, and because I am consistency is the hobgoblin of small minds, but I like to see the same thing. Okay, scenario number 2 is they say, no, we're a better content creation payer. We're going to pay you $200,000. I say, great. And they say, well, by the way, in the small print, it's actually $100,000 20 years from now, in year 20. And it's in year 40, it's another $100,000. Okay. So in a total, you're going to pay me total. I'm going to sum these up. I think you can do the math in your head. $200,000. So company number 2 is going to pay me $200,000 for my YouTube content creation. The other one's going to pay me $25,000. Which one is worth more? Well, you might have a suspicion that, well, if they pay you so far in advance, 20 years from now and 40 years from now, we might have to do some heavy discounting of that value. But let's actually add math to it. I'm going to use the same. I'm going to use a Y in the scenario, a discount rate in scenario 1, which I'll write down here, of 7%. Okay, let me widen that out. And I'm going to use the same discount rate of 7% for the other offer. Now I'm going to set up a series of calculations we'll call this present value. Present value. Wonder if I'm running out of space here. And present value. And I'm going to just create a little table so I can compare the value of these two scenarios. Scenario 1, let's start with the first payment. It's 1 year from now. It's $5,000. I'm going to put the discounting cash flows formula right here in cell D9. To start a formula, I do the equal sign, equals. Then I'm going to put in it's equal to FV. The FV in this case is $5,000 in 1 year. Boom. Now I'm going to divide that by 1 plus the discount rate, which I put down here as 7%, All that raised to the power of the n. How many years am I discounting? 1. $5,000 1 year from now at 7% discount rate is worth $4,672.90 once I change this with a little currency button to dollars. It's important in discounting multiple cash flows that you present a separate calculating formula, a separate PV equals FV over 1 plus Y raised to the power of n for each future cash flow. You can't just sort of add them all up, make it $25,000 and say, discount me $25,000. No, in fact, as this video, it's sort of maybe this is the point of the whole video, each separate payment needs its each separate calculation. So in year 2, the $5,000, I'm going to create a separate formula, but it's the same pattern we've been using. Equal sign, the amount of money in the future value, divided by 1 plus Y, all of that raised to the power of 2. Not surprisingly, now that shouldn't be I'm going to change this to a currency function because it's somehow gotten into its head that it's a percent function. Currency function, there we are, $4,367.19. Notice that this is less than that, even though it's the same starting amount and it's the same discount rate. The difference is that one is discounted for 2 years and that one is discounted for 1 year. I'm going to do the same thing here just to belabor the point, but show that you could plug in the formula again, 5,000 divided by 1 plus the discount rate, all raised to the power of 3, and that will be less than the first two ahead of it. Now, hopefully you know about the autofill function, which I'm going to show right now, which is I'm going to lock in a cell, which is specifically D16, the discount rate there. I'm going to put little dollar signs in front of that, which locks that, which allows me to drag and autofill the next few boxes, and it will continue to reference the D16 spot. Now I have a total worth, I'm going to sum these up for these boxes, so $20,500.99. So in plain language, this contract to create content to be paid $5,000 each year for the next 5 years is worth today $20,599. How does that compare to this seemingly more rich offer of $200,000, but I'm going to be paid in year 20 and year 40? This is an exaggerated example, but roll with me here. So I'm going to put these scenario number 2 right here in this box. I'm going to create a discounting cash flows formula for the $100,000 in 20 years by starting an equal sign. $100,000, similarly going to divide that by 1 plus the discount rate, which I've plugged in here. Raised to the power of 20 years of discounting, and that one is worth $25,000, $841.90. Okay, so although this is, we could say a few things. One is that's worth a fair amount of money. It's significantly less than the $100,000 that it appears to be, but okay, it's something. And in the next scenario, I'm now going to discount this other 100,000, equal sign, equals divided by 1 plus the Y function, raised to the power of 40 years of discounting. Change that to a currency function. Boom, that's worth $6,678. So way less than the $100,000 nominal value, but still something. I'm going to total those up for comparison's sake right down here. And we could say that that $200,000 offer in today's terms is worth $32,000. I think that's very useful to know that if our assumptions are correct, which is 7% discount rate, that that's still worth more than the $25,000 offer from scenario number 1. Now the neat thing, here's where we find it very useful, the neat thing about discounting cash flows, multiple cash flows into your spreadsheet is it's very easy to change assumptions. Let's say in fact these companies have a different risk associated with payment. One company is the established leader in the space and we trust that they're going to be around in 5 years. We might say, well, that's not a very risky situation. If it's not risky, we might say it's more like a 3% discount rate. So I'll do a different Y and I'll change all of these assumptions. I'll just shift it downward, ready? And I'm going to lock in this cell I could have just put it in the other way, but let's see. Change all that. And that raises the value of the $25,000 offer immediately to $22,898. I changed that to 3% to show what the not risky why would be. The other way I could have done it, I'll change it back now so that you can see. Do another autofill. We're back, and now I can, of course, change this at will, and you'll see the numbers shift. If it becomes more risky, it's worth $18,000. If it becomes very less risky, it's $24,000. Similarly, over here, I could say, well, this company that's promising me these payments, this Shangri-La in the future of $100,000 each year in 20 years and in 40 years, that's an incredibly risky startup company. I don't believe they're going to be around in 40 years. Maybe the correct discount rate there is 25%. Risky company, 25%. When you discount something as heavily as 25% for as many years as 20 years, you can see the value is just a mere fraction in present value terms of the original offer. So that total offer is worth $1,166.21 if we believe this company to be very risky, and that's reflected in that discount rate of 25%. Similarly, as I'll just go quickly through this, let's say it becomes less risky. Now it's worth something, even less risky. Yeah, it's getting better, 10%, still a heavy discount. If we get into the scenario of, well, actually this company's going to be around. Let's say it's not a startup company, but it's the US government. They're definitely going to be around, and well, fingers crossed, they're going to be around. We'll consider it not risky, a 2% discount rate. Well, now that $200,000 offer is worth quite a bit more. I hope by showing you these different payments or multiple payments in a spreadsheet, you can see how you can quickly make comparisons about future payments. Thanks for watching.